Today we are going to learn nomenclature. So let's read from the book. Alcohol. The common name of an alcohol is derived from the common name of alkyl group and adding the word alcohol to it. For example, CH3OH. This is derived from methane. So when you name the molecule, you will name it as methyl alcohol. According to IUPAC name, the name of alcohol is derived from the name of alkane from which the alcohol is derived by substituting E of alkane with suffix OL. The position of substituent are indicated by numerals. For this, the longest carbon chain, the parent chain, is numbered starting at the end nearest to the hydroxyl group. The position of OH group and the other substituents are indicated by using the number of carbon atom to which these are attached. For naming polyhydric alcohol, E of alkane is retained and the ending OL is added. The number of OH groups is indicated by adding multiplicative prefix di, tri, etc. before OL. The position of OH groups are indicated by appropriate locate OH, CH2, CH2, OH. Here the longest carbon chain is 2 carbon long and there are 2 OH groups. So the name of this molecule will be ethane 1,2-diol. Table 7.1 gives common name and IUPAC name of few alcohols as examples. So let's try to name each molecule. So let's revise the rule of IUPAC nomenclature. In the first step, you have to select the longest carbon chain. Longest carbon chain, which will be the parent chain. Then now identify the substituent. And third, number the chain so that functional group gets the lowest possible number. Number the chain and functional group should get the lowest possible number. For alcohol, suffix is OL. Suffix is OL. Now try to name each molecule. First of all, select the longest carbon chain. So here it is just 1 carbon long chain. So the parent is methane. And you have to add suffix OL. So the name of this molecule will be methanol. Now come to the second example. So first of all, select the longest carbon chain. So here it is 3 carbon long chain. Now number the chain so that OH group gets the lowest possible number. So here we will number from the right direction 1, 2 and this is 3. So the name of this molecule will be propane 1-ol. You have to substitute E of alkane with OL. So here the name will be propane 1-ol. Now come to the next example. Here first of all select the longest carbon chain. So here it is 3 carbon long chain and OH is bonded to second carbon. So the name of this molecule will be propane 2-ol. Now come to the next example. Here the longest carbon chain is 4 carbon long. So the name of this molecule will be butane 1-ol. Now come to the next example. Here again the chain is 4 carbon long and OH group is bonded to second carbon. So the name of this molecule will be butane 2-ol. Now come to the next example. Here the longest carbon chain is 3 carbon long and there is a substituent. Here the substituent is of methyl. Now number the chain so that functional group, which is OH, will get the lowest possible number. So we will number the chain from right direction. So here this is 1, 2 and 3. Methyl is bonded to second carbon. So you will write 2-methyl propane 1-ol. Now come to the next example. Here first of all select the longest carbon chain. So the longest carbon chain is 3 carbon long chain. And there is 1 methyl substituent which is bonded to second carbon. And OH is also bonded to second carbon. So the name of this molecule will be 2-methyl propane 2-ol. Now come to the next example. Here there are two OH groups and the longest carbon chain is 2 carbon long. For polyhydric alcohol, you have to retain E of alkane. So here we will write ethane 1,2-diol. As there are two OH groups, you have to use di in front of all. Now come to the next example. Here there are 3 carbon and 3 OH groups are there. So the name of this molecule will be propane 1,2,3-triol. Now come to the cyclic alcohols. They are named using the prefix cyclo and considering the OH group attached to carbon 1. Means wherever OH group is bonded, it will be considered at first position. For example, in the first case, it is cyclohexanol. In the second example, OH is bonded to this carbon, so this carbon will be considered as 1 and this will be the second carbon. So the name of this molecule will be 2-methyl cyclopentanol. Now come to the phenols. The simplest hydroxy derivative of benzene is phenol. It is its common name and it is also accepted as IUPAC name. As the structure of phenol involved a benzene ring, in its substituents compound, the term ortho, meta and para are often used in common names. So here, this is the phenol, common name and IUPAC name, both are phenol. In the second example, here methyl substituent is there. This is the first position and this is the second position. So here, so the name of this molecule will be 2-methyl phenol and the common name is orthocresol. In the second example, here methyl group is at third position because OH is considered at first position 1, 2 and this is third position. So the name of this molecule will be 3-methyl phenol and the common name is metacresol. In the next example, here OH group is at first position and this is second, third and this is fourth position. So methyl is bonded to fourth position. So the name of this molecule will be 4-methyl phenol and the common name is paracresol. Dihydroxy derivatives of benzene are known as 1,2, 1,3 and 1,4 benzene diol. The common name of benzene 1,2-diol where the OH group are just adjacent to each other. They are called as catechol. In the second, where OH group are at alternate position, it is first position and this is third position. This is called as resorcinol. And when OH are diagonal to each other, this is first position, second, third and next OH is at fourth position. So it is called as hydroquinone or quinol. Now come to ethers. The common name of ethers are derived from the name alkyl or alkyl group written as separate word in alphabetic order, adding the word ether at end. For example, CH3O C2H5. This is ethyl methyl ether. In both alkyl groups are same. The prefix di is added before the alkyl group. For example, C2H5O C2H5. To both sides C2H5 and C2H5 is there. So the name of this molecule will be diethyl ether. According to IUPAC system of nomenclature, ether are regarded as the hydrocarbon derivative in which hydrogen atom is replaced by OR or OAR group, where R and AR represents alkyl or allyl groups. The larger R group is chosen as the parent hydrocarbon. The name of few ethers are given as examples in table 7.2. So let's discuss the name of different ethers. In the first example, here CH3OCH3 is given. To both sides, same methyl group is there, so we can write, in common name you can write dimethyl ether. But the IUPAC name of this ether will be methoxymethane. The common name for ether is alkyl ether. This is the common name system, and for IUPAC this is alkoxy alkane. So alkane will be the larger R group and alkoxy will be the smaller R group. The name of this molecule will be methoxymethane. In the next example, C2H5O C2H5. On both the sides, C2H5 group is there. So you can write ethoxyethane. Now come to the next example. Here, this side, on one side of oxygen, methyl group is there. On the other side, propyl group is there. So this will be the parent alkyl group. And this will be the alkoxy group. So the name of this molecule will be methoxypropane. Here this is methoxypropane. As methoxy group is attached to first position of propane. This is 1, 2 and 3. That's why 1 is written before methoxy. Now come to the next example. This is C6H5OCH3. This aryl group is bigger than this alkyl group. So it will be considered as parent chain, and this alkyl group will be considered as alkoxy group. So the name of this molecule will be methoxybenzene. This is methoxybenzene. Now come to the next example. Here C6H5OCH2CH3 is there. Here again aryl group is bigger than this alkyl group. So this will be the parent, and this alkyl group will be the alkoxy group. So the name of this molecule will be ethoxybenzene. Now come to the next example. Here C6H5O CH2 whole 6 CH3 means there are 7 carbon long chain on this side and there is 6 carbon long benzene. So this will be the parent and benzene part will come as alkoxy. So here you will write the name of this molecule as 1-phenoxyhaptane. Now come to the next example. Here the longest carbon chain. Here CH3 group is there on one side, and on the other side 3 carbon long chain is there. So when you select the longest carbon chain, this is 3 carbon long chain. So this will be the parent and this part will go as alkoxy part. Now number the chain so that this alkoxy part get the lowest possible number. So you can number from either direction. So if I write it here 1, 2 and this is 3. So this methoxy is attached to second position of this propane. So the name of this molecule will be 2-methoxypropane. Now come to the next example. Here C6H5 is on one side of oxygen and on the other side 1, 2, 3, 4 carbon long chain is there. So benzene will be the parent and this part will be the alkoxy part. For this alkoxy part, you have to name it as a separate molecule. First of all, select the longest carbon chain. So here this is 4 carbon long chain and this is the substituent. The carbon to which oxygen is bonded will be considered as first carbon. So this is 1, 2, 3 and 4. So the name of this alkoxy part will be 3-methyl-butane. So this is 3-methyl-butane, but here you have to attach oxy. So here we will write 3-methyl-butoxy and the parent is benzene. So the name of this molecule will be 3-methyl-butoxy benzene. Now come to the next example. Here there are two ether groups are there. In one part, methyl on the one side, and here CH2, CH2, again O, CH3 is there. This is the parent chain, and this is one carbon and this is second carbon. To one carbon methoxy is attached, and on the second carbon again methoxy is there. So here you will write 1,2-dimethoxy ethane. Now come to the next example. Here this is cyclohexane at O C2H5. So obviously this will be considered as alkoxy part, and this is the parent. So if we number this carbon as 1 and this is 2, so these two methyl will get 2 number. So 2 plus 1 oxy. So you will get 5. But if I number this carbon as first carbon and this is as second carbon, so both the methyl will get first number 1 plus 1 plus this ethoxy will get 2 number and the sum will be 4. So as the lowest sum rule, you have to follow the red one numbering. So that's why the name of this molecule will be 2-ethoxy-1,1-dimethyl cyclohexane. Now let's try to solve these questions. Give IUPAC name of the following compounds. So here first of all identify which are the functional group. So here OH is there and one Cl is also there. But OH is get preference over Cl. So OH is the main functional group and Cl will be considered as a substituent. Now select the longest carbon chain. So here it is 1, 2, 3, 4, 5 carbon long chain. So here we can number it 1, 2, 3, 4 and this is 5 carbon long chain. And there are substituents. So this is one methyl substituent, this is another methyl substituent and this is Cl. So when you name this molecule, you have to name in alphabetic order. So first of all you have to name Cl, then we will write methyl. So when you write the name of this molecule, you will write 4-chloro-2,3-dimethyl pentane 1-ol. Now come to the next example. Here the functional group is ether. And on the one side 3 carbon long chain and on the other side 2 carbon long chain. So 3 carbon long chain will be the parent chain. Now number the chain. So this is 1, 2 and 3. At second position ethoxy group is bonded to propane. So the name of this molecule will be 2-ethoxy-propane. Now come to the next question. Here this is benzene to which OH is bonded, means this is phenol. So this is phenol and on one side CH3 substituent is there and on the other side also CH3 substituent is there. So first of all you have to number this chain starting from the OH. So this is 1, 2, 3, 4, 5 and 6. So the name of this molecule will be, so this is 2,6-dimethyl phenol. Now come to the next example. Here OC2H5 is there, means this is ethoxy and nitro group is bonded to this carbon. So when you number this chain, you will number it from here 1 and this is 2. So the name of this molecule will be 1-ethoxy-2-nitro-cyclohexane. Now let's try to solve these questions. Name the following compound according to IUPAC system. Now let's try to solve first question. First of all, select the longest carbon chain that includes your functional group. So here, starting from CH2, which is bonded to OH, CH, and this will be the longest carbon chain, as it includes your functional group. Now identify the substituent. So here there is one, this bigger substituent, and this is another substituent. As this is a complex substituent, you have to name it separate. Now select the longest carbon chain to which it is bonded to the main chain. So here it is 2 carbon long and there is another substituent, methyl. So here this is another methyl substituent. When you number this chain, you have to number it from the carbon to which it is bonded to the main parent chain. So here this is first carbon and this is second carbon, and to the first carbon methyl substituent is bonded. So the name of this complex branch will be 1-methyl ethyl. Now name the another substituent. So here this substituent is chloromethyl. Now number the parent chain. So we can number it from the carbon to which OH is bonded. So here this is 1, 2, 3, 4 and this is 5. Now write the name of this molecule. On writing the name of substituent, you have to cite them in alphabetic order. So first of all, we have to write chloromethyl, then we will write 1-methyl ethyl. So let's write the name of this molecule. So chloromethyl is bonded to third carbon. So here we will write 3 chloromethyl. Now the second substituent 1-methyl ethyl. It is bonded to second carbon. So here we will write 2 in bracket we will write 1-methyl ethyl. Then write the name of parent. As the parent is 5 carbon long, the name of parent will be pentane and OH is bonded to first carbon. So here we will write pentane 1-ol. Instead of writing 1-methyl ethyl, you can also write isopropyl. Both the names will be correct. Either you can write 1-methyl ethyl or you can write isopropyl. Both the names will be accepted. Now come to the second question. Here there are 2 OH groups. Now you have to select the longest carbon chain that includes both the OH groups. So here I can select from here CH2 here till here. Now number the chain. So 1, 2, 3, 4, 5 and 6. Now identify the substituents. So there is CH3 substituent and there is another CH3 substituent. One is bonded to second carbon, the other one is bonded to fifth carbon. Now write the name of this molecule. So let's write the substituent first. So 2, 5 dimethyl. It is polyhydric alcohol. So here you have to write the name of parent with E. As it is 6 carbon long, the parent will be hexane 1,3-diol. 1,3-diol. Now come to the third question. In third question, it is cyclohexane and there is a substituent of bromine. When you number it, you have to number it from the carbon to which OH is bonded. So it will get first number, this is second and this is third number. So when you write the name of this molecule, you will write 3-bromo cyclohexane 1-ol. Now come to the fourth question. Here there are 2 functional groups. One is ene and other one is OH. So here you have to select the chain which includes both the functional group. So this is the longest carbon chain that includes our both functional groups. Now number the chain. 1, 2, 3, 4, 5 and 6. As it is 6 carbon long, the parent will be hex. So here we will write hex. Double bond starts from first carbon. So here we will write 1 ene. And OH is bonded to third carbon. So here we will write 3 ol. Now come to the fifth question. Here again OH functional group is there and double bond is also there. So again you have to select the chain in such a way that includes both the functional group. So here you will get 4 carbon long chain. There are two substituents, one is methyl and other one is bromine. Now number the chain so that functional group gets the lowest possible number. So here you have to number it from right direction 1, 2, 3 and this is 4. Now name this molecule. As we are going to cite the substituents in alphabetic order, first you have to write bromo. So here we will write 2-bromo, 3-methyl, bute, 2-ene, 1-ol. In the next video of alcohol, we are going to discuss structures of functional groups.